Hi, welcome to Ready to Go On, the module quiz. Here we go. I'll get my pen ready and, oh, actually, this right here. Number one, graph the image of triangle ABC after a translation of 6 units to the right and 4 units down. Label the vertices of the image A prime, B prime, and C prime. Okay. Then, what we got? What? 6 to the right and 4 down. So 6 to the right, I'll go here, 6 to the right, 1, 2, 3, 4, 5, 6, and 4 down, 1, 2, 3, 4. And the first point is right there. A prime is at, what, 2, 1. So A prime right there. And then the rest will just follow. What B prime is down 2 from that. So B prime is right here. And C prime is 3 to the right of B prime. 1, 2, 3. Yeah. So 1, 2, 3. C prime would be right here. And there's my triangle right there. That's number one. Now, on the same coordinate grid, I'm going to make this in blue, graph the reflection about the x-axis. Okay, so the x-axis is the horizontal line, and I'm going to count. Let's go for B right now. So I count first to the line of reflection. So 1, 2, 3. So it's going to be B prime is going to be 1, 2, 3 below that, and that makes it 1, 2, 3. So that makes B prime right there, and A prime is going to be far. Oh, you know what? I put that in the wrong spot. Let's put B prime to the side here because A prime is going to be too farther away than that. So too farther away, A prime would be here. And C prime is 1, 2, 3 to the right of it. So 1, 2, 3. So C prime would be right there. And this is our triangle reflected about. Oh, and this has to be double prime. Double prime there. Okay. And there you go. Okay, number 3 is graph the image of HIJK after it's rotated 180 degrees about the origin. Label the vertices H prime, I prime, J prime, and K prime. Let's see. The formula, I think I remember that. I always like to use the formula. The formula is, I'll go green on this, x, y maps to the opposite of x and the opposite of y. I happen to remember that. It's not terribly complicated. So what I want to do, I'm going to zoom in a little bit farther here, and I'm going to use that. I'm going to label each vertice. So I'm going to make this. Okay, I think that's good. So anyway, I'm going to label all the coordinates. So this is 0, what? 0, 1, 2, 3, 4, 0, 4. And so that means it's going to map to the opposite. See, I'm going to look. So xy maps to the opposite of x and the opposite of y. So that means that's going to be 0, the opposite of 0 is 0, and then 4, the opposite of 4 is negative 4. Okay, I'm just going to do all the points first. So this I is, that's 0, 1. So it's going to map to, when I rotate 180 degrees, it's going to be the opposite of x and the opposite of y, negative 1. And then this one is J. J is, I'm going to do it here. J is what? Negative 2, positive 2, negative 2, positive 2. And that maps to the opposite of x, which is 2, and the opposite of y, which is negative 2. Okay. And then K is going to be what? The point is negative 2, 1, 2, 3. So this is negative 2, 3. And that maps to the opposite of that is what, 2, and the opposite of 3 is negative 3. So I have all my points here. I just graph all those points. So the first one I'm going to do this one, 0, negative 4, and then this one, and then I'm going to do that one, and then that one, and then we'll see the rotation. I think I'm going to do it in yellow. So 0, negative 4, 0, 1, 2, 3, 4, 0, negative 4, and I'm going to call this H prime. because it's the rotation of h. And then I prime is going to be 0, -1, which is right here, I prime. And 2, -3, 2, 1, 2, 3. This right here is 2, -3 is k prime. And then I prime is 2, -2. 2, -2. Something is not right. Because this is not good. I must be one off on this. Let's see if I can fix this. So this is for 1, 2, 3, 4. Oh, look at that. That's that h right there. Darn you, h. Let's fix you. So 1, 2, 3, 4, h prime must be there. And then I'll close this off like this. There you go. That is the rotation, 180 degrees. Okay, so let's get back to number 4. Says a triangle has vertices 2, 3, -2, 2, and -3, 5. What are the coordinates of the vertices after the image translation of that? Well, all I have to do is add 4 to the x and subtract 3 from the y. So 2 plus 4 is, let's see, how should I show you this? I'll do red. So it would be, if I have 2, 3, then that would be 2 plus 4, and then 3 minus 3. 3 minus 3, right? So, you know what? I need more room for this. I'm just going to put it over here. I'm not going to try to squeeze this. There's no need for me to try to squeeze this stuff in here. I'm going to show you as it properly should be done. So x, y maps to x plus 4 and y minus 3. So the first one is 2, 3. So it's 2, 3. That's the first point. And then I have to add 4 to that, and I have to subtract 3. So that would be 6 and 0. So the first point is 6 and 0. Okay. The next point, and I'm eyeing this right here, -2, 2. Okay. How about I just erase that and that and this and this. And I put -2 and 2. Right, that's the x and y coordinates of the next point. And that -2 plus 4 is 2, and 2 minus 3 is -1. So the next point is 2, -1. And then I'll erase the other stuff. Erase this for our next point, which is right here, -3 and 5. So this is -3 and this is 5. And -3 plus 4 is 1, and 5 minus 3 is 2. So it should be 1, 2. And I'm yep, got it all. Okay. Vocabulary. Translations, reflections, and rotations produce a figure that is congruent. Yeah, they are the same, congruent. Same size, same shape. That's what congruent means to the original figure. And use a coordinate grid for exercise 3. Reflect h prime, I prime, j prime, k prime over the y-axis, then rotate 180 degrees about the origin. Label the new figure h double prime, I double prime, j double prime, and k double prime. Holy moly. We're going to be doing a bunch of stuff here. So I have to reflect this, and then I have to rotate it. Okay. So I'm going to zoom in on this, make it nice and big, and I realize right now I'm going to have to erase this stuff here because this is where my last one's going to be. Okay, so step 1, reflect. I have to reflect this about the y-axis, so it's going to be over here. And then I'm going to rotate it 180 degrees, so it's going to go over here. Okay, so a reflection, I'll do it in this color. So the reflection is going to be, that's going to stay there, and then, oh, J. This has to be J prime. Okay, so J, anyway, J is going to be 1, 2, 1, 2. J is going to be here, and K is going to be here, and H is there. So this is what I got here when I reflected about the y-axis. Now I have to rotate it. I have to rotate this. This has to get rotated 180 degrees, so it's going to be brought over here. Okay, how about this? If I have, if this one got rotated 180 degrees over here and then reflected, then 180 degrees reflected over here, it's going to look like this. I'm just going to draw it out for you. Because I could do all the points and switch them all up like I did before. But if we think about this a little bit, it'll just look like this. It'll look like this. This, and then this will be 2 off of that. This will be 2 off of that, and this will be there. And it'll look like that. And they want us to, we have to label these correctly. So this will be H double prime. This will be I double prime. This will be K. This will be K double prime, because this is getting brought all the way over there. Okay, but I'm going to do that right there. And then this will be J double prime. J double prime. That's what it looks like. Okay, finally, we have the last question. What properties allow transformations to be used as problem-solving tools? Well, let me fill it in for you. Well, what we could say is transformational properties allow systemic movement. Of congruent figures while maintaining or adjusting their orientation. Or adjusting their. Okay, so let me explain what this means. So the properties of the transformations allow you to systematize. It's just a system. It's really like a process of moving these figures while maintaining or adjusting their orientation. So sometimes the orientation is maintained, or sometimes the orientation stays the same, or sometimes the orientation is adjusted or it's moved. Let me explain. We have here from this one to this one, the orientation means what direction is it facing. Well, on this translation, the orientation is the same. It's facing the same direction. But on this one here, this reflection, the orientation is changing. It's being flipped. So sometimes the orientation is changed and sometimes it stays the same. And so that's what that orientation means. Yeah, and congruent figures, every time we do this, the figures are always congruent, meaning they're always the same. These are the same shape, same size. These are the same shape, same size. All of these are the same shape and same size, but their orientation is changing sometimes. And it really only changes from here to here, it changed on that rotation, and here to here, and from here to here, it changed on the reflection. So the reflection changes, the reflection and the rotation changes the orientation. But the translation does not change the orientation. It just slides it. That's all you got to know for this. I hope this has been helpful. Thanks for watching.